Once we have the reactions, we have a second question that is to calculate the deflection and the slope at the cross section D in the plane of symmetry. So the slope of D is going to be the slope of D in the symmetric case, and the slope plus the slope of D plus the slope of D in the antisymmetric case. So we know that the slope of D in the symmetric case is equal to 0, and we can calculate then the slope of D in the antisymmetric case because of the force P, okay, in AB. So this is PA squared divided by 8EI plus 9 over this is the contribution of the shear force, okay, so 9 over 8, the shear force multiplied by 8 squared divided by EI. Okay, so we use in both cases the formula for the slope of a cantilever beam with a force at the free end, in the first case with the length A divided by 2, in the second case 3A divided by 2. So if we calculate this addition, taking into account that B sub D is minus 4 divided by 27, what we have is 1 divided by A minus 4 divided by 27 multiplied by 9 over 8, and this is equal to PA squared divided by 24 EI, okay, PA squared divided by 24 EI, that is the slope of the cross-section D. Regarding the deflection of the cross-section D, we have the deflection of cross-section D in the symmetric case plus the deflection of the cross-section D in the antisymmetric case, and we know that the second addend is equal to 0. Okay, that the deflection in the plane of symmetry in the antisymmetric case is equal to 0, so we can calculate the deflection of D in the symmetric case. So we have, because of the distribution of load in CD, we have PA, that is Q, multiplied by length to the 4th power divided by 8. Okay, so A divided by 2 raised to the 4th power divided by 8. And then in bending, because of bending in A, B, C, we have the effect of the force P divided by 2 and the effect of the bending moment P divided by 2 multiplied by A divided by 4. Okay, so we can write this expression plus the effect of the bending moment in the cross-section D that produces. So we have the effect of bending in CD because of this distribution of force P over A, the effect of bending, as we saw before, in ABC because of the equivalent force and moment system, that is force P divided by 2 and moment P divided by 2 multiplied by A divided by 4, and the effect of bending in the complete half length of the structure because of the moment at the free end of the cantilever. Okay, so we can calculate the addition of these taking into account the value we calculate for the bending moment at D. Okay, so PA cubed divided by 128 EI plus PA cubed, divided by 6 EI plus PA cubed divided by 16 EI, okay, minus the bending moment that was equal to 13 divided by 36 multiplied by PA multiplied by 9 over 8A squared divided by EI, and this is equal to P a cubed divided by ei is cubed, is not square, is cubed, a cubed multiplied by 1 divided by 124, 1 divided by 6, 1 divided by 16, plus minus 13 divided by 36, sorry, 32, okay, divided by 32, because it's already multiplied by 9 over 8. So this is equal to 158 divided by 768 pa cubed divided by ei. And we correct here this that is a square.